Okay, still on the maximum bending moment, you have it as WL square over 8. Okay, that is in the case of a simply supported beam. Okay, now the next thing you are expected to look at is the effective the effective depth of slab. Now, how do you calculate for effective depth? Effective depth is D equal to your H minus cover minus 1 over 2 diameter of bar. Okay, the bar here is the reinforcement, okay, to be used. All right, so for example, you have your slab in this format, okay, then the height, the overall height is your H, okay, that's your overall height, okay. Now this becomes your overall height. The distance between this point to this point becomes your H, okay. So now you substitute, usually for slab is 150, okay, is 150. Then we now have the cover as 25, okay. Then we have, if you're using 12 mm, it becomes half of 12 mm. That gives you the effective depth of the slab. Then the next thing you're going to look at is the K value. Okay, you have to look at your K value. Okay, the K value here, is usually your M, okay, over FCUBD square. Okay, that is your K value. Then you also look at your lever your lever arm. Your lever arm is 0.5 plus square root of 0.25, okay, minus K over 0.9. Then after this, you have to look for your lever arm, which is your LA times your effective depth. Okay, now from here, now you look for the area of steel, and your area of steel is your moment divided by 0.95 FYZ. Okay, now this becomes your AS required. Okay, this becomes your AS required. So this M becomes your moment, which is the moment gotten at this point. The moment gotten, okay, that is your M, okay, previously. So you have 0.95 FYZ, and it's going to be in millimeter square. That will be the unit. Okay, so take note of that. So from here, your K value, you have your moment divided by FCUBD square over 2. Now what this simply means is that your M now, your M is your design, your design moment rather. Your design moment. Okay, that is M. Then your FCU becomes the characteristic strength of concrete. Okay, then the B is the breadth, the width or breadth, which is the area you're considering. For example, you have this now as your slab. Okay, if this is 3 meters at the short span, so this becomes 3000 millimeter. Okay, this becomes 3000 millimeters. Then your D is equal to the effective depth. Effective D. Okay, that is effective depth. So that is for the K value. So you have to calculate your K value. Now if you look at this sequence now, your LA is your lever arm factor. Lever arm factor. Okay, you have to calculate it. So the K that you got here, the K value you got here, you have to substitute it into this equation, okay, and compute whatever the outcome is. For you now to calculate your Z, which is your lever arm, okay, you have to multiply your LA times your effective depth. You have to multiply your LA by your effective depth. So whatever it gives you, you bring it down to your area of steel required. AS required, that is area of steel required. So it's going to be your moment divided by 0.95 FYZ. Now your FY is your strength of steel. Your strength of steel. That is tensile strength. Okay, so when you do that, you have succeeded in designing your slab. Okay, that is the design procedure for your slab. All right, so when you follow up this process, this is then whatever you get here, whatever you arrive here, you now take it to a table where you have various areas and their reinforcements provided. Okay, you have to now look at the area that suits the one you have calculated, if it is in line with, if the area is okay, as in with the one you have calculated, then you can now choose the reinforcement type from that table. Then also, after you have done this, you have to check for deflection. Okay, you have to check for deflection, which will come in our next class. Okay, you have to check for deflection. If deflection is excessive, that means you have to redesign. You have to redesign the slab, okay, so that the slab can be stable. All right. So this is a procedure on how we are supposed to design our slab. Okay. So I'm going to stop here for today. I expect if there are questions, okay, because this is going to be an interactive class. So questions, you send questions across based on what we have done so far, then answers will be given, and that will cover the time, the duration for the classes. Okay, so at this point I'm going to stop here for today. Thank you very much for your time, and God bless you. Thank you.